Welcome to Boson Buzz, where we dive into the coolest scientific ideas and breakthroughs shaping tomorrow's world. When we look at a modern skyscraper, we see a monument to human ambition, a symbol of unwavering strength that appears to stand perfectly still against the sky. We perceive it as a rigid, immovable object, defiantly rooted in the ground. But this perception is a powerful illusion. The truth is, these colossal structures are constantly in motion. They are not rigid. They are engineered to be flexible, to sway in the wind, and to absorb the immense energy of earthquakes. If they were completely rigid, they would be brittle, and the forces exerted by a major storm or seismic event would cause them to crack and potentially fail. This necessary flexibility is a key principle of modern structural engineering. However, this movement creates a significant problem for the people inside. In a strong wind, the swaying of a very tall building can be pronounced enough to cause noticeable disorientation, motion sickness, and even anxiety among its occupants. The gentle, slow rocking can make pictures hang crooked and cause water in a glass to slosh. The fundamental challenge for engineers became clear and critical. How do you allow a massive building to move as physics demands without letting the people working and living inside feel a thing? The solution lies not in fighting the forces of nature, but in outsmarting them with an elegant hidden device. The solution to this problem of motion is not to make the building more rigid and fight against the immense power of the wind, but to use the fundamental physics of motion against itself in a brilliant display of counterintuitive engineering. This is achieved through one of the most brilliant and deliberately hidden feats of modern structural engineering, the tuned mass damper, or TMD. Often located at the very top of a skyscraper, concealed from public view within a specialized mechanical floor that visitors never see, this device is the building's secret guardian, its internal balancing heart that operates silently around the clock. In its most famous and iconic form, perfected and publicly showcased in buildings like Taipei 101, it is a colossal pendulum, a massive sphere or a block of steel weighing hundreds or even over 1,000 tons suspended high above the city like a massive stationary wrecking ball. But this is not a fixed, static weight. It is a dynamic, precisely engineered counterweight, designed to swing freely on a carefully calibrated system of steel cables, lubricated bearings, and hydraulic dampers that control its movement. This massive ball is the building's silent partner in an intricate, perpetual dance, a completely passive system that requires no external power source to function, relying only on the intelligent and precise application of fundamental physical laws, inertia and harmonic motion to keep everyone inside the structure safe, comfortable, and completely unaware of the atmospheric turbulence outside. The principle behind the tuned mass damper is one of elegant and powerful simplicity, based on the fundamental physics of inertia and resonance. When a strong wind pushes the entire skyscraper in one direction, the colossal weight of the suspended damper, due to its own inertia, wants to stay right where it is. It resists the motion. Imagine a pendulum hanging in a car that suddenly accelerates. The pendulum swings backward. This is exactly what happens on a monumental scale. As the building sways slowly to the left, the giant damper ball swings to the right. Then, as the building sways back to the right, the ball now swings to the left. This opposing, out-of-phase motion creates a counterforce that actively absorbs and dissipates the kinetic energy of the building's sway. The damper doesn't stop the building from moving. It cleverly converts the energy of the movement into its own motion, effectively canceling out the larger, more nauseating oscillations and turning what would be a noticeable and unsettling sway into a gentle, almost imperceptible drift that the human body can barely register. While the swinging pendulum is the most iconic and easily understood version, capturing the public's imagination, the same core physical principle is applied in other ingenious and often more compact ways to suit different architectural needs and spatial constraints. Some of the world's tallest and most slender buildings, where a swinging ball would be impractical, use a different system known as a sliding mass damper. This involves an enormous block of concrete or lead weighing several thousand tons, placed on a lubricated, low-friction metal surface at the top of the building, effectively creating a massive sliding scale. When the building sways, this incredible weight slides smoothly in the opposite direction, guided and controlled by a sophisticated network of hydraulic pistons and springs that convert the dangerous kinetic energy of the building sway into harmless heat, which is then safely dissipated into the building structure. Another innovative version, used in many Japanese skyscrapers, is the tuned liquid column damper, which uses a massive, shallow tank of water. As the building moves, the water sloshes back and forth at a carefully tuned frequency, creating its own counter rhythm to dampen the vibrations. Whether the system swings, slides, or sloshes, the ultimate engineering goal is identical: to be the building's internal, automated balancing system, an invisible, intelligent hand that constantly and automatically works to maintain perfect equilibrium and human comfort against the relentless, unpredictable, and powerful forces of nature, proving that the most effective solutions are often those that work with physics, not against it. These hidden dampers are the unsung heroes that make modern megastructures and super tall skyscrapers not just possible, but also practical and comfortable for human occupation. They are the reason why thousands of people can live and work in serene comfort a quarter of a mile in the air, largely unaware of the powerful winds buffeting the tower outside their windows. This technology represents a fundamental and profound shift in architectural and engineering philosophy. We are no longer just building stronger and heavier. We are building smarter and more responsive. We are designing structures that can dynamically interact with and adapt to their environment in real time, using intelligence embedded in their very form. The tuned mass damper is a silent, powerful testament to this human ingenuity, a hidden, beating heart that works in perfect rhythm with the building it protects, ensuring that our tallest and most ambitious architectural dreams remain not only standing, but perfectly, serenely, and safely calm. The concept of the tuned mass damper is not brand new. Its fundamental principles have been understood in classical mechanics and engineering for over a century, applied to steady machinery and reduce vibrations in bridges. However, its critical application to skyscrapers became an absolute necessity as buildings began to soar to previously unimaginable heights and, paradoxically, became more lightweight and flexible due to the use of advanced high-strength steel and reinforced concrete. This push towards the clouds created a new problem: manageable but perceptible and uncomfortable sway. One of the most famous and dramatic early examples is the story of the Citicorp Center, now 601 Lexington Avenue in New York City. In the late 1972, after the building was complete, it was discovered that the structure was vulnerable to certain, specific storm winds, a terrifying revelation. The building was secretly and urgently retrofitted with a tuned mass damper, a project conducted under the cover of night to avoid public panic, which highlighted the critical, non-negotiable role of such devices in ensuring public safety. Today, nearly every super tall skyscraper in the world, from Taipei 101 with its iconic, publicly viewed golden sphere to the Burj Khalifa, which relies on a more complex system, depends fundamentally on some form of this technology. It has rapidly evolved from a specialized, last-resort engineering solution into a standard, indispensable, and proactively designed component of cutting-edge architectural design, a required and non-negotiable feature for any structure that hopes to safely touch the clouds and provide a habitable environment for its occupants. As we continue to push the limits of height and design, the role of these hidden damping systems will only grow more critical. They enable the creation of ever more slender and aesthetically daring towers that would otherwise be uninhabitable due to their movement. The future may see even more advanced and integrated systems, potentially using AI to predict and preemptively counteract sway based on real-time weather data. The tuned mass damper in all its forms embodies a beautiful paradox. To achieve perfect stillness, we must incorporate intelligent motion. It is the ultimate symbol of our understanding that we cannot conquer nature's forces, but we can learn to dance with them. So, the next time you are in a skyscraper during a storm and feel nothing but calm, remember the unseen guardian above you, the silent giant performing its endless, elegant ballet in the sky, making the modern skyline not just a spectacle of height, but a marvel of stability and comfort. If you found this as fascinating as I did, do me a huge favor and hit that like button. Share this video with anyone who loves science or just cool, futuristic tech. And of course, if you want to stay updated on this and other amazing breakthroughs, make sure you subscribe to the channel. Thanks for watching, and I'll see you in the next one.